Now, we will discuss Chapter 1.5, Differences between metals and non-metals. We may list out the differences between the elements through comparisons. Comparisons are normally conducted in a same condition of environment. For example, same temperature and same pressure condition. In general, comparison between metals and non-metal is conducted in room temperature and 1 atm pressure. Except the boiling and melting point comparison. Melting point and boiling point of elements is compared under the pressure of 1 atm. The metals and non-metal are different in their physical properties. The following are the physical properties for the comparison between metals and non-metals. The first, appearance. Metals are shiny, and non-metals are dull. Second, the ductility. Ductility is ability of material to undergo significant plastic deformation before rupture. Metals is ductile, that it will undergo plastic deformation before rupture. Non-metals is not ductile, that it will not undergo plastic deformation before rupture. We can say non-metals is brittle. The third is malleability. This is the ability to undergo significant plastic deformation under the pressure. Metals is malleable. Non-metals is non-malleable. Fourth, electrical conductivity. Electrical conductivity is the ability of a material to conduct electrical current. Metals have high conductivity. Non-metals have low conductivity. The fifth, heat conductivity. Heat conductivity is the ability of a material to conduct heat. Metals have a high heat conductivity, whereas non-metals have a low heat conductivity. The sixth, melting point. Melting point is the temperature where the solid started become liquid. Metals have a high melting point, whereas non-metals have a low melting point. The seventh, boiling point. Boiling point is the temperature where the liquid started become gas. Metals have a high boiling point, whereas non-metals have a low boiling point. The eighth, tensile strength. Tensile strength is the force required to pull a material to the point where it breaks. In general, metals have a high tensile strength, whereas non-metals have a low tensile strength. Density. Density of a material is the mass quality of the material that found in 1 unit of its volume. In general, metals have a high density, whereas non-metals have a low density. The 10th, state of matter. State of matter is referring to either 3 states of matter, in solid, liquid or gas. It is depend of the arrangement of elements within the material. For metals, they usually existed in solid state, except the mercury. Mercury exists in liquid state in room temperature. For non-metal, most of them existed in either solid or gas, except the bromine. Bromine exists as liquid in room temperature. This table is for you to overview the differences between metals and non-metals. We will talk about some examples of metals and its applications. Aluminium. Aluminium is an element with symbol Al arranged in the periodic table. It is gray in color, a shiny solid in nature. It is strong, light, ductile, and malleable. It is a good conductor of electricity and heat. It is a rust-proof material. Aluminium is used to make aluminium foil, food and drink cans, kitchen utensils. The next example to be discussed is copper. Copper is the element with symbol Cu, arranged in periodic table. Copper is a reddish-brown solid in nature. It is ductile and malleable. It conducts electricity and heat. It is a rust-proof material. Copper is used to make electrical wires, heating pipes, and roofing. Gold. Gold is the element with symbol Au, arranged in periodic table. Gold is a golden yellow and shiny solid. It can be easily pressed into required shapes. It is a rust-proof material. For application, gold is used to make jewelries. The fourth example is iron. Iron is with symbol Fe, arranged in the periodic table. Iron is a gray solid. It is strong, ductile, and malleable. It conducts electricity and heat. It can be attracted by magnet. For application, it is used to make railway tracks. The fifth example is silver. Silver is the element with symbol Ag, arranged in periodic table. Silver is a silvery solid. This make the silver in good reflective of. For application, it can be used to make mirror. The sixth example, zinc. Zinc is the element with symbol Zn, arranged in periodic table. Zinc is a bluish-white solid. Zinc is strong, ductile, and malleable. Zinc is a rust-proof metal. Zinc can be used to make roof tile. The last example here is mercury. Mercury is the element with symbol Hg, arranged in the periodic table. Mercury is the silvery liquid at room temperature. Mercury has a high boiling point. It expands when heated. For application, mercury is used in thermometers and barometer. The discussion for the mentioned metals, for their properties and application end here. Here is some examples of non-metals, for discussion. We have 5 examples here. The first example here is iodine. Iodine is the element with the symbol I, arranged in the periodic table. Iodine is a purplish-black solid in nature. It is toxic. It is an antiseptic. It is used to make antiseptic medicine, to protect wounds against bacterial infection. The second example, chlorine. Chlorine is the element with symbol Cl, arranged in the periodic table. Chlorine is a greenish-yellow gas. It is toxic. It is bleaching. It can be used to make bleaching agents. The third example here is carbon. Carbon is an element with symbol C, arranged in the periodic table. Carbon is a black, light, and smooth solid. Carbon is the non-metals that keep electricity. For application, it can used to make racket, pencil leads, and electrodes in dry cells. The fourth example is sulfur. Sulfur is the element with symbol S, arranged in the periodic table. Sulfur is a yellow powder, it is in solid state. Sulfur is toxic. For application, it can be used to make fireworks, paints, and cleaning agent. The last example here is oxygen. Oxygen is an element with symbol O, arranged in the periodic table. Oxygen is a colorless gas. It aids in combustion. Oxygen is used to make fuels for rocket, and to be contained in oxygen tank. These are the examples for non-metals element. Now, we are in the topic appreciating the order of elements that exist in the nature. The elements that have been discovered by scientists are valuable and beneficial to our life. The completion of the periodic table is the efforts of scientists who have discovered and studied the elements. We should appreciate the scientists who had contributed their efforts. For the completion of the periodic table, scientists who had contributed to the completion of the periodic table is as follows. Antoine Lavoisier, a French chemist who classified elements into metal and non-metal. He is known as father of modern chemistry. For another contribution, he helped construct the metric system, a system that used to perform measurement. Johann W. Dobereiner, a German chemist who come out a triad table, a table that group 3 element have similar chemistry properties, into one group. For other contribution, he invented the first lighter. John Newlands. John Newland was a British chemist, who did work concerning the periodicity of elements. He arranged all elements in ascending order of their atomic masses. From the arrangement, every eighth elements repeated the similar chemical properties. This arrangement of elements is known as the law of octaves. Lothar Meyer. He was a German chemist. He tried to arrange the elements according to the atomic volume. Dmitry Mendeleev. A Russian chemist. He arranged the elements in the ascending order of atomic mass. Elements with similar chemical properties were placed in vertical column. Empty space is left for undiscovered element. These of those undiscovered element was able to be predicted. Henry Moseley. He was an English physicist. He arranged elements in the ascending order of proton number. These are the 6 scientists and their contribution to the development of the periodic table. So far, we have just done the discussion for the topic 1, classification of elements.